Hello, I'm Jason Goray with the Minnesota Population Center, and I'd like to thank you for taking the time to review this walkthrough of the proposed Terra Populus extract making process. Terra Populus will allow people to get integrated data on human population characteristics, land use, land cover, and climate. This data will be interoperable across both time and space and will be available to the public. Initially, Terra Populus will focus on three kinds of data: census and survey microdata, describing the characteristics of individuals and their families and households; area-level census and survey data, describing aggregate population characteristics of places; and finally, raster data, describing land use, land cover, and climate characteristics. Terra Populus users will be able to make extracts combining data from different sources into the output type of their choice: microdata, area data, or rasters. For the purpose of exploring the system, we are taking the role of a researcher who is interested in studying the impact of malaria on gender ratio. The data we have in the system which best predicts mosquito, and therefore malaria, exposure may be precipitation and proximity to water. The user wants to get an area-level population and environmental data for Brazil and Malawi, which they can then study in their choice of statistical packages. Upon entering the data extract system, they are presented with an initial screen. At this point, no filters have been applied, no data input variables have been selected, and the user has not yet started browsing the data groups. Because they want area-level data, they are going to start looking at the area data group, so they click on the area data group dropdown. The user will need general population characteristics for their study, so they click on the general population data group. Our researcher sees the general population data groups, which currently contain only the core demographics group. The population data in Terra Populus are derived from census samples, each identified by a combination of country and year. Variable availability is initially shown for all census samples in our database. For this prototype, the only census samples we have are the recent census years in Brazil and Malawi. In order to see all available variables, the user expands the groups population by married status, age 16+, as well as total population by sex. In order to make a gender ratio, our user needs to know the total population and wants to see more detailed information about the total population variable, so they click on the total population variable name. The details on the total population variable are shown. It looks good, so the user clicks Add Variable, which adds this variable to their data input cart. Because they have added a census-based variable, they will at some point need to select the census samples for which they want the variable. They are presented with a list of available census samples and encouraged to make that choice now. At this point, the total population variable has been added to their data input cart, and if they close this window without selecting samples, the variable will be added to the data input cart, but with no samples selected. If they select census samples now, they won't be prompted to select them again. The samples selected here will be applied to all future census-based variable selections. If desired, the user can change census sample selections from the data input cart or later in the process. The Use Selection as Filter option is checked and will enable filters based on these sample selections. These filters will limit which variables and census samples are displayed while they browse the data groups. This option can be disabled if the user still wants to see all variables for all samples. The user selects Brazil 2000, Malawi 1998, and Malawi 2008. This looks good, so they click Add. Because they have added an area variable, our researcher will at some point need to select the geographic levels for which they want the variable. The default is all available levels. The variable and their sample choices have been added to their data input cart, and if they close this window without selecting geographic levels, those selections will remain, but geographic levels will not be added. The user isn't sure how first and second level administrative relate to things they're familiar with, so they expand first and second level administrative. For the purposes of this walkthrough, we're pretending we have no data from Malawi at the second administrative level. The user decides they only want levels that are available for both Brazil and Malawi, and they deselect the second level administrative. This looks good, so they click Add. The user is returned to the list of general population variables, but can now see a summary of the inputs that they added. Because they allowed their sample choice to be used as filters, availability is now only shown for the samples they selected. If any variables are not available for any of the samples, they will not be shown. To get the other half of their ratio, our researcher will need to know the total population of at least one gender, so they add total female population. A second variable has been added to their data input cart, with the same census sample and geographic level selections as the user chose for total population. Now, the user needs to get some information about precipitation and proximity to water bodies. That sort of climate and land cover data may be available in raster format, so they click the Raster Data Group dropdown. Precipitation data is probably included in the climate group, so the user clicks the Climate Raster Data Group. For the purposes of this study, annual precipitation will be sufficient, so our researcher adds the variable precipitation annual. No further information about the precipitation annual variable is needed at this point, so it is added to the data input cart. Now they need to find out about the presence of water, so the user clicks on the Raster Data Group dropdown. Among these categories, data on water is most likely to be under land cover, so they click land cover. The land cover raster data is displayed. Currently, all of the land cover data is derived from the Global Land Cover 2000 dataset. The user has the option of selecting a variable that includes all of the classes in the dataset or variables that indicate the presence of specific land cover types. Our researcher is specifically interested in water, so they add water bodies. Again, it goes right into the cart. At this point, the user believes they have the variables they need, so they click Show Selections to double-check their data inputs. Because the user was on a raster screen when they clicked Show Selections, the Data Inputs cart pop-up opens on the Rasters tab. They can click through the other tabs to verify their other inputs, so they click on the Area Variables tab. This looks good, so they click on the Countries, Years, and Geographic Levels tab. And this looks good, so they click Close. They are returned to the land cover screen from which they entered the data cart view. They are satisfied with their data inputs, so they click Continue. The user is now on the second step of the process, selecting data options that will determine how the variables they selected as input are integrated into their data extract. At this point, they have the option of selecting a data output format or going back and adding more data inputs. They are unable to select microdata as an output format because they have no microdata inputs. The Continue button on the cart is disabled because they can't go on to the summary and checkout until they make a few more choices. Since our researcher wants an area data extract, they click Get Area Data. The user is presented with a grid showing the availability of their variables for the census samples and geographic levels they have selected. If they are unhappy with what they see, they have the option to go to their data input cart and change things. Our researcher takes a moment to check their variable availability. And even though they're only going to be able to get their gender ratios nationally, they click Continue. For each of the raster variables, the user is given a list of available operations. These operations are used to summarize the input raster data values within each geographic unit to a single value for the unit. Each operation will generate a new area level variable. Our researcher accepts the default selections and hits Continue. The user is shown a final summary of their area data extract and is given a final opportunity to edit their selections before submitting it. In this case, since they have not yet logged in, they would be expected to log in before the extract is submitted. We appreciate that you have taken the time to review the proposed process for making an area data extract using the Terra Populus system. Please direct any comments, criticisms, or general feedback to terrapop@umn.edu. Thank you.